This is our video for Monday, May 4th for pre-cal, and our objective today is arithmetic sequences. You'll need your books open to page 567, kind of our week this week. On Monday, we're going to do arithmetic sequences. Tuesday, we're going to talk about the sum of an arithmetic sequence. Wednesday, we're going to talk about geometric sequences, and Thursday, we'll talk about geometric series. And then all the homework is due Thursday by midnight, and then we will have our quiz on Friday over sections 8.2 and 8.3. All right, so first thing you're probably saying is that this word is arithmetic, which is true, but it can also be pronounced arithmetic, which is the way it is pronounced when you are talking about an arithmetic sequence. And an arithmetic sequence is a sequence in which the difference between consecutive terms is constant. It is a sequence in which the difference between consecutive terms is constant. So first of all, consecutive means one right after the other. Difference means subtraction. And so the difference between consecutive terms is a constant. So if we have 2, 5, 8, 11, difference, consecutive, 5 and 2, 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, and so the difference between consecutive terms is constant, it's 3. Another way to look at it, it is when you have a number that's being added each time to get the next consecutive term. Think about arithmetic, adding. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So it's really when you're adding something to get to the next term. Now this common difference is labeled D. So let's go ahead and turn to page 573 and look at some of the problems. On the first section, on 1 through 8, they are giving you a sequence, and they're asking you if it is arithmetic. They're asking, is there something that's being added each time to get to the next consecutive term? So if we look at number 1, we've got 10, 8, 6, 4, 2, so forth and so on. So if you just want to be very literal with your equation, or with your definition, so you would go 8 minus 10 is negative 2, 6 minus 8 is negative 2, 4 minus 6 is negative 2, and again, you don't have to show that much work, but the answer is yes, and the common difference is negative 2. So we say that we're adding to get the next term. It could be a negative number. So this is going down because we're adding a negative 2 each time. All right, number 3. We have 3, 5 halves, 2, 3 halves, 1, so forth and so on. So if you have 5 halves and you're subtracting 3, you get negative 1 half. If you have 5 halves if you have 2 and subtract 5 halves, you get negative 1 half. And so basically they're just adding negative 1 half, subtracting a half each time, so that common difference is negative 1 half. This might be easier if you think about the decimal. This is 3, 2.52, 1.51. If we look at number 8, we have 1 squared, 2 squared, 3 squared, so forth and so on. That is not, so this one would be yes. Common difference was negative 1 half. This would be no. There is no common difference. If we look a little further down the page at number 11, we have an explicit formula like we talked about last week. Directions are: write the first 5 terms of the sequence. Determine whether or not the sequence is arithmetic. If it is, find the common difference. Assume n begins with 1. So our first term, we would put 1 in, and we're going to get 1/2. Our second term, we would put 2 in, and we're going to get 1/3. For our third term, we're going to put 3 in, we'll get 1/4, and then we would get 1/5. And they want 5 terms, so this is 1/6, and this is not arithmetic. So kind of playing off of what we did last week, they're going to give you an explicit formula. They want you to write down the sequence and then say yes or no whether it is a arithmetic or not. Now, if you look at 17 through 26, it says find a formula for the nth term of the arithmetic sequence. And they're telling you the first term, well, the first few problems are telling you the first term and the common difference. All right, so last week, on Tuesday, I believe it was, you were given a whole list of different sequences, and you were supposed to come up with the explicit formula. Arithmetic sequences, I didn't tell you at the time, but arithmetic have a formula that can be used, an explicit formula. And let's see if I can help you to understand where it comes from, and then or how it's kind of developed. All right, so this is the sequence that we started with earlier, and 3 is being added each time. So remember that last week we had to kind of think about, what are they doing to the number of the term to get the next number in the sequence. So let's just think about this for a minute. This is 2. This was 2 plus 3. 8 is 2 plus 6. 11 is 2 plus 8. 2 plus 9. And then for 14, we have 2 plus 12. So 2 plus nothing, 2 plus 3, 2 plus 6, 2 plus 9, 2 plus 12. So we're taking 2, and this would be 0 times 3. This would be 1 times 3 would be the 5. And this would be 2 times 3. This is our first term. This is our second term. This is our third term. Our fourth term, so that would be 2 plus 3 times 3. And for our fifth term, we have 2 plus 4 times 3. So the first one was just 2, and then we added 1 3, then we added 2 3s, and then we added 3 3s, and we added 4 3s. And so this is hopefully leading us to the explicit formula for any arithmetic sequence. And so this was our first term. Well, let me write it like this. A sub n. Our first term was the 2. 3 was our common difference. Now, this was our first term, and we multiplied the 3 by 0. This was our second term, and we multiplied by 1. This was our third term, and we multiplied by 2. So they're taking the number of terms and subtracting 1 and multiplying it by that common difference. So to get the nth term of an arithmetic sequence, you're going to have to take the first term, and you're going to add to that the common difference 1 fewer times than the number of terms, because you got your first term here, and then this was our first term, then our second term, we multiplied by 3, we added 1 3, and then we added another 3, and then we added another 3, and then we added another 3. This is our fifth term, but we've only added 4 3s. So that being said, if they would ask us for the 10th term in this sequence, we would start with our first term is 2. And if we want the 10th term, we would have multiplied 3 by 9 to get 27 plus 2 more is 29. So if we were looking for the 10th term, we would have started with 2, and then we would have added 3 9 times to get to that 10th term, which is 29. So if we look at number 19. The directions are find a formula for the a sub n for the arithmetic sequence. So on number 19, they're telling us that the first term is 100 and that the common difference is -8. And so we have this formula right here. So for the nth term, we would start with 100 and we would have n minus 1, and our common difference is 8. So you're just plugging in the formula. It doesn't ask you anything else. It just wants to know what is the formula for this arithmetic sequence. So that one's very straightforward. Number 25 is a lot more interesting. So in 25, they're telling us the third term is 94. I'm going to write that down here. And then they're telling us the sixth term. So they're not telling us the fourth or the fifth, but they're telling us the sixth. And they're saying that the sixth term is 85. Okay. Now they are telling us that this is arithmetic. So they are telling us that there is something that was added. In this case, we're getting smaller, so it's a negative number. It was added here, and then from here it was added again, and then added again to get this. So the way I would do this is I know that the same thing was added here, and was added here, and was added here. So I would take and try to figure out, what is the difference between 85 and 94? Well, that's -9. Okay, so and this happened 3 times. So the difference from here to here is -9, and this happened 3 times. So I'm kind of looking for the average here. So -3 is what was added each time. So 94 plus -3 is 91. 91 plus -3 is 97. No, excuse me. Would be 88. Sorry. And then 88 plus -3 would be 85. All right, so I've got the common difference. What I don't have is the first term. But this was the third term, and so if I go in reverse and I add 3, I'd have 97 for the second, and I would have 100 for the first. So my formula, a sub n, would be 100 plus n minus 1 times -3. Okay? Now, I know this is going a little bit long. I want to show you one more thing real quick, kind of tie it to last week. If we look at number 35, it says write the first 5 terms of the arithmetic sequence, find the common difference, and write the nth term of the sequence as a function of n. And so they are giving us that weird formula from last week. This was the recursive. And so it's basically telling us that we are adding 4 each time, and we're starting with 15. So 15 plus 4 is 19, 19 plus 4 is 23, 27, and 30 would be the first 5 terms. Then they also want us to write an explicit for the nth term. And so we know the first term is 15, and we know the common difference is 4. And so then we can plug that into our formula. So just a little bit different, just kind of tying the recursive to the explicit. All right, your work for today is going to be in your book on page 573. I want you to do the even 2 through 24, 36, and 40. And remember that Zoom is available every day at 10 o'clock if you have any questions.